Without further ado, I'm going to get Jim up here to, looks like better testing with given, when, and then is the topic he has chosen.
Well, actually, we have two.
Oh.
So it's this one or that one. Let me describe. So what I'm going to do is I'm going to describe them to you. I want you to think about it. I'm going to go off for a tangent for just a minute or two. And when I come back from the tangent, we'll have a vote. Show of hands to which topic you'd rather hear. Okay? So the Kata and analysis is a live coding session where I solve a very simple code kata live in front of you, live code it. And then after I'm done, I'll stop and I'll review what I did and the decisions I made along the way. It's an example of doing test-driven development and how that all kind of feeds into the whole process. So that's one talk we can do. The other talk is a talk on the RSpec given library. This is a library I've been working on for about 4 years or so. It's not a complex library. It's just a lot of love and care has gone into just tuning it and making it exactly right. And I think it's really time for people to hear about this library now, so I want to talk about that as well. So think about that. The given, when, then, RSpec given library, or a live coding session with analysis following. One of those two. Think about that. While you think about it, I want to show you what we're playing with back in Cincinnati, our latest toys. And bring this up here. There we go. That is a Parrot AR drone flying thing. My office mate Karen Meyer is flying that one right now. I think in a little bit we'll turn around here and you'll see us standing there in the background. There's Karen. I'm standing by her. It's being filmed by my drone. So we have 2 drones flying in the room right now. And Karen's trying to fly it around the room, and I'm trying to do the thing where I fly around but keep my camera pointed at it while she's doing it. And we're still kind of learning how to pilot that. So you can see we've got a nice open atrium area in our office, and it's a lot of, this is just doggone fun. This is pure geek toys right here. There she goes. She has a little problem with the wall there. Okay, she's coming around. I'm swinging over. Don't have to watch this whole thing. I'm going to skip to the end. I'll show you what happens when your drone runs out of battery. So there I'm flying, and oh, there we go. I wasn't watching the battery meter close enough. Okay, so that's the fun stuff we're doing, but let's tie that back into Ruby. So here, I'm writing a library, and it's really hard to see in this picture, but you can see at the top we're requiring our library called Argus. We create a drone object, drone.new. We tell the drone to start, we tell the drone to take off. It sleeps for 5 seconds. Then twice, we go left, sleep a second, go right, sleep a second. Then we'll do it again, left, right, sleeping a second each time. We hover for a second, then land. So this is under programmatic control, the AR drone flying. Okay, hit start there. And I'm going to hit the return there. I just hit the return. There's a 5-second sleep before it starts. So I'm running over to the other side of the office. And we take off. Left, right, hover, land. Boom. The library is really primitive right now. There's all kinds of navigational data that the drone can feed you. The drone has a high-definition camera pointing out the front. It's got a low-definition camera pointing down. It's got a sonar altimeter that it can tell how high it is off the ground. It has a barometric altimeter, so if you take it outside and fly it up higher than 20 feet, it still knows how high it is. You just, when you're flying it, take your thumbs off the control, and it just stops and hovers. So it's a great learning tool. It's a really fun little thing that we've been playing with. I'm writing a Ruby library to control it, and Karen's writing her library in Clojure. So we've got a little fight going on right now. So that's the fun stuff that I'm doing right now. So with that out of the way, let's go ahead and have a show of hands on which presentation you want to hear tonight. How many want to hear the code kata and analysis with the live coding? Okay, lots of hands. The other one, RSpec given. Oh, it's really close. Okay, RSpec given, I'll actually have to count here real fast. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. About 12, 13. Okay, it's looking like Kata and analysis. Oh yeah, that wins. Rats, you're going to make me do live coding. I knew I should have practiced this before I came tonight. Okay, Kata and analysis. So what is a code kata? Code kata is just a simple exercise that you perform over and over again to teach yourself programming skills. Actually, not to teach yourself, but to make those skills kind of innate, automatic, so that when you get down to the crunch of pressure and deadlines, you don't skip on the good habits that you've developed in practicing these katas. The katas themselves are not hard. You could do this Roman numeral kata like that probably very easily. But I'm stepping through, and what I'm going to reproduce tonight, live coding, is pretty much what I did the very first time I did this. So you're going to see a lot of the same concepts and ideas that I went through as I was doing this. So the kata itself is a task to convert a decimal number to Roman numerals, okay? So let's do the kata right now. I'm going to switch over here to my editor. Let's see here. Let's get rid of that X thing. That was a little test thing. So let's create a Roman numeral converter spec, because we always start with a spec, right? I'm going to use rspec given. See, you thought you weren't going to get anything about rspec given tonight. Okay. Then let's describe the Roman numeral converter here. And I always like to start off with a really simple specification. So given a converter that is the Roman numeral converter.new, then when I call the converter with a convert method, and I give it the number 1, I am going to expect that. I'm going to change this up. I usually use should. I'm going to use this technique right here. I'm going to expect that to equal I. Okay, so I'm going to have to configure something here just real fast, quick. rspec given use natural assertions. Okay, so let's run this test. It's going to complain it fails because we don't have a Roman numeral converter object anywhere. So we got a first failing test. Excellent. So let's go and require the Roman numeral live coding, right? Typing counts. Converter file. And let's go ahead and create that, and we'll go ahead and create a class, the Roman numeral converter class in there. That looks good. Let's run the specs. And it fails because there's no method convert in there. Okay, fair enough. Let's add the convert method. Define convert. It takes a number n, and we're going to run this. And it fails now because it expected a nil, but it was expected nil to be equal to I. So then here, this is what rspec given gives you, is it says, okay, this returned false. This sub-expression here, the converter.convert of 1, actually returned a nil. So we really want that to return an I. So let's go back to this and have it return an I. And we're done. Actually, we're not done. That was just one test. Yeah. So, okay, here we go. Let's do another test. Then with an N, converter convert 2 will be equal to II. Ah, here we go. Run this. We get one failure. Expected I to equal II because the converter is still returning an I. I got to return the number of I's equal to the number, that looks like. So let's go here. Oops. Let's go here, and that's easily done by saying star n. Because I'm laughing, I'm serious here. Okay, let's run the code. Green test, yes! So, next test. What should we do next? Ah, I heard 3, I heard 5, I heard 4. I think, 0 is a good choice too. I'm going to skip 3 because I don't think 3 will tell us anything new. Because 3, I'm pretty sure 3 will just work as is. I'm going to skip 4 because I think 4 is a special case. And I don't know how to handle the special case. I don't even know how to handle the general case yet. So I don't want to deal with special cases yet. So let's go to 5. That's a pretty straightforward one. So converter on 5 should be V. Run the tests. And it fails because we get 5 I's. That's exactly what we thought it would do, right? And we wanted to get a V. Okay, if n is 5. Okay. Next test. I'm thinking 6. What do you guys think? There's always one in the crowd. Who called out 10? Who's the heckler over here? Okay, okay. Just, I got my eye on you. All right, let's do 6. And that fails because we get 6 I's. Okay. Let's think about this. So if 6 comes in, I really want the V to come out. So this test really should be greater than or equal to 5. And then once that's done, then I need some extra I's to come out here. Maybe the thing to do is to say, okay, I think we need to build up a result incrementally. Okay, so we're going to change the code around a little bit. And just a little refactor, so I'm going to mark this guy as pending for the moment. Pending. That means all my tests will pass. Good, okay. And let's go and refactor this to have a result. That is the empty string. And then we will put V into the result. And let's reduce n by 5 because we've handled, we've handled 5 out of the number, so we'll reduce it by 5. And then we will stick onto the end of the result anything remaining, any part of the number that's remaining. Okay, so there should be n should be 1 at this point when it comes into 6. It should be 1 here. I think that will work. And our tests still work there. All the regular tests work. And let's remove the pending here and run it, and we're good to go. We handled 6. Again, I don't think 7 is going to provide more insight. Neither will 8. 9 is another special case. Let's do 10. Ten is like this. Oops. 10 is like that. There we go. Run it. It will fail. We got a V and 5 ones, and we want just to have an X out of that. So I see a pattern here. If n is greater than or equal to 10, let's put out an X and reduce the number by 10. Oops. And it passes. Excellent. When I'm going, sometimes I go too fast, and I don't pause on the screen that is green, because I'm really excited, I want to get back. So when you're following along, it's a little hard sometimes. So if you go too fast, say, hey, Jim, slow down. That's okay. Okay, so everything's passing. Excellent. Let's do 20 now, because I think 2 X's would be very interesting. And yeah, so we're getting the 10, but then we're getting the V, and then we're getting all the 1s out. What I really want to do in here is not just test if it's greater than 10, but say while it's greater than or equal to 10, put out an X and reduce it by 10. So we want to make that into a while loop now. Yeah, excellent. See, I'm beginning to see a pattern now to this. Okay, what comes after 10?